Hello, everybody. I wanted to explain the circuitry behind the wah pedal that I created for my daughter. So basically, it took a little bit of research, but it turns out all it is a multiple feedback narrow band pass filter that's based off of an inverting amplifier, op amp. So it's going to be I'm going to explain it as best as I can based on what I've learned from it, but here goes. So, multiple feedback. What does that mean? There's multiple feedback to an op amp. So it basically starts out with an inverting op amp configuration. If this is your op amp, this is your inverting input, this is your non-inverting input, this is your output. There's a positive voltage going in here, negative voltage going in here, and a ground. So in the standard non-inverting op-amp configuration, this goes to ground, which is not the negative voltage. This circuit is created by basically taking the positive rail and the negative rail and making a separate ground in between the two. So if this was your power supply, and this is your ground, you connect your negative voltage to here, your positive voltage to here, then you create a resistor ladder, voltage divider basically, and this is your ground signal that connects over here. So in any case, so the way the multiple feedback narrow band pass filter works is you have your audio signal coming in here, and of course the other side of it goes to ground. This is your audio signal. It passes through a resistor. There is another resistor here that goes to ground. Then what happens is you have your multiple feedback. So the signal, before it goes through here, passes through a capacitor and goes in here. But there's a feedback loop here. There's two feedbacks. That's why it's multiple feedback. One is a resistor, and another one is another capacitor. I'm going to do my best to explain how this all works. So basically, if you look at it really carefully, these are all active filters. So right here, this right here becomes a low-pass filter. So what does a low-pass filter mean? Low-pass filter means that anything below a certain frequency is not attenuated and is gained. And that value is calculated basically by a formula, and the frequency, the cutoff frequency, is equal to 1 over 2 pi times the value of the resistor times the value of the capacitor. And it's the same calculation for a high-pass filter, which you see here. Now, how does this work as a high-pass filter? Basically, high frequencies are passed through very easily through a capacitor. Low frequencies do not pass through a capacitor very easily, and what happens is the capacitor, for instance, in the low-pass filter area, right, the low frequencies don't pass very easily to the capacitor, and so the resistance of this becomes very high. And if you, for anybody who knows about how a non-inverting or inverting op-amp works, the gain of an op amp is basically the resistance here over the resistance here. And so as the resistance here goes up, the total gain becomes much higher for in this case, the low pass, the lower frequencies. For the high pass, it's the exact opposite. The high frequencies will go through, and there's much more gain for the high pass filter, high pass frequencies going through this aspect of the filter. So what this does, and then this is the output, and let me just draw that in, and that's your output to your speaker or your amplifier in the case of a guitar, and so on and so forth. So how do we build this circuit? So the circuit basically is designed based on what your frequency cutoff range is going to be. So with a multiple feedback bypass filter or bandpass filter, the way this works is that this gives you an extremely narrow range, or it can give you an extremely narrow range of the frequency that you want amplified versus the frequencies that you want cut off. And so that is defined by a number called Q, which is the quality factor. And basically all that means is it's the center frequency of where you want to of what you want to amplify over the frequency high minus the frequency low, basically the bandwidth of the area. So, the higher this number gets, the more quality of the amplification in a specific frequency you get, and the narrower the bandwidth around that frequency is. So if you were going to graph it in terms of gain versus frequency range, based on whatever values of capacitors and resistors you choose, if you make it a really high quality, a high Q, it will look something like this, where this is your F high, is your F, or your F low, I'm sorry, this is your F high, and this is your FC. And the narrower this gets, the higher the Q gets. And so, this has been, there are plenty of videos out there that show how to properly design this. But basically, with this circuit, you actually have this other resistor here, which functions as a voltage divider at this point right here. So by varying this frequency with a potentiometer, you can vary the actual center frequency around which you're providing gain and attenuating the rest of the signal. And all of this is done by just varying one component. So if you put a potentiometer on it, which is basically what the pedal does, the pedal just adjusts the potentiometer, you can actually change you could actually easily change this frequency. And so I'll explain that in a second. So basically, the way this is designed is that this is R1, this is R2, and this is R3. And typically the values that you put in here and the capacitors C1 and C2 should be equal. So C1, I'll write it here, C1 equals C2 equals C, and we'll just call it C. And so what you do is you calculate what frequency low you want to pass, and what frequency high you want to pass, and this becomes the FL, and this becomes the FH, and this value is typically much smaller. Typically, R1 is half of R2. So if you were going to select a resistor here, in my case for the wah pedal, I selected an 80K resistor here. So therefore, this is 160K for the wah pedal that I built. So for R3, and this is the interesting part, this is typically a very much lower value than the R1. And because you don't want it impacting this too much at the beginning of your circuit. However, it turns out that there's a way to calculate what your R3 is going to do to the center frequency. And typically, that is this equation. So if you want to change your center frequency from FC to FC prime, right here, you basically take the value using this equation. You can calculate the new value of R3 that you would want in that area. So whatever you would adjust your potentiometer to change your cutoff frequency, and the potentiometer is very easy to quickly change the value when you want to quickly change the effect. If you were building an amplifier and you want to, or something else that's going to require a precise frequency cutoff, then that is what you would have to change, and it's a more fixed value. But if you could adjust it with a potentiometer quickly, that is a quick way of adjusting your signal. So based on this, you can rearrange the formula, rearrange the equation to tell you some relationships here. So here, your new center frequency is basically related to the old center frequency times the square root of R3 over R3 primed. And so you could basically say that as this resistance goes down, using a potentiometer, for instance, as this goes down, the center frequency goes up of your narrow bandpass filter. So what does that mean? That means that if you decrease the resistance at the R3 point, you are going to get a higher frequency, a higher center frequency at which point that has the gain, and all other frequencies are attenuated. So what does that mean? In the case of a guitar, when you step on the wah pedal, you're basically, we have it set to the R3 going down to a much lower value. And when there's a much lower value, this center frequency goes up, and you get a much more trebly sounding effect, because that's at the higher frequencies. And when the pedal goes backward, the R3 goes up, and the center frequency goes down, and so you get amplification at the more the bass side of the spectrum. So going back to this circuit, this is where your potentiometer would be at R3. So the way I have the circuit laid out is I have the R3 as a 500 ohm resistor, which is way smaller than the 80K resistor that I have in R1, and I have that in series with 10K potentiometer. So the lowest so if I draw this out here, imagine that's right here. If I draw that out over here, and over here I have a 10K potentiometer. The lowest that, because I have this in series, if the 10K potentiometer is turned down all the way to 0, basically you have no resistance here, and the minimum amount of resistance I have here is 500 ohms. So you can adjust this value to whatever you want to make it even a lower value when you step on the pedal all the way. But when the pedal gets turned all the way backward, the maximum resistance is 10K. And so you can imagine what that's going to do to this to the filter up here in terms of the low pass cutoff. It's going to make that low pass cutoff go way down. And so you're basically going to take this signal and shift it to the left as you increase the resistance. And as you decrease the resistance, you're going to shift this all the way to the right. And you're going to get a much more, the center frequency is going to be a much higher value. It's going to be a cutoff in this range. It'll look something like this. So all of this can be calculated out, using this formula for where your cutoff frequencies are going to be. And so in this case, some people put an actual, an additional resistor here. I didn't use it, but other people have, and it doesn't really change much in terms of what you get out of the signal. And the R2 value, this typically would, if you put a resistor here, it would be same value as R2. And that's the way the template works for creating a multiple feedback narrow bandpass filter. The capacitor value you use here has to be equal. So in my case, I used a 10 nanofarad capacitor, which is easy, have them laying around, and it was much easier to find. And so you can basically, I adjusted these so that they would be within the range of what a guitar frequency spectrum would sound like. Obviously you want to do it within the audio spectrum because I'm dealing with audio here. But you could use something like this for building a filter for something else, some other signal that's much higher frequency. You would obviously have to adjust these values. But this multiple feedback narrow bandpass filter is ideally suited for the wah pedal because using a simple potentiometer, you can adjust and you can change the entire effect just by changing one component and very quickly using a pedal effect. And so all I did was I took a potentiometer, and this 10K potentiometer that I had, I basically, if you look at it from the side, to build a circuit, I glued it or affixed it to the wall of the pedal, and to the other side I attached basically a piece of wood, a block of wood, if you watch the other video that I made. And around this piece of wood, I just tied a cable, or I basically screwed a cable to this piece of wood. And that cable just swivels this potentiometer back and forth based on the effect of the pedal. If you look at the pedal from the side, this was where it took a little trial and error to do. But if this is the pedal, and if you're going to look at the whole wah pedal from the side, you have this potentiometer here with the block of wood sort of going into the page here. And what it is basically you have this, I used an electrical cord. It wasn't that exciting, but as this pedal swivels up and down, this potentiometer rotates this way or this way. And as I have it set so as it rotates this way, as the pedal gets pushed down, it rotates this way, and it gets turned down to 0 ohms, which, as it's connected in series with 500 ohms, becomes a resistance of 500 ohms. And the maximum value becomes, as it gets swiveled all the way backward, the resistance increases, and it becomes at a maximum 10.5 kilo ohms. And at this level, the low pass filter goes significantly upward in the frequency cutoff, and the entire graph here shifts to the right. And as it shifts to the right, you get more amplification at the base level, and as it shifts as it shifts to the right, it gets more to the right, you get more amplification at the treble level, and to the left, it gets more amplification at the base level. So hopefully that explains how the circuit is built. And the op amp I used, you can use any op amp, LM741. I didn't use an LM741. I use an LM324, which is a quad op amp, and it's not, if you ask anybody, it's not the ideal op amp. It doesn't have high slew rate or any of that stuff. But for my purposes, it didn't really matter. I had a whole bunch of them laying around when I ordered one for the other circuits I built, and it tends to be it works just fine. Basically, it works just fine. We don't really need we have it set up here, so it's basically unity gain, not a lot of gain at all, because all the gain is done by the main amp that the guitar is plugged into. But if you want gain, you can adjust the resistor values to give you proper gain also at this point. And you can use a different op amp, TO81, LM358. You could use any op amp. But as long as it's set up in this configuration, it works. So if you're going to do the entire circuit, you basically have the LM 324, which basically has power, VCC, ground rail in the middle. Well, this is the negative voltage rail, actually, and the way it's set up is it has 14 pins, and pin 1, 2, and 3 over here. If you draw the chip this way, pin 1, 2, and 3 over here. This is the positive input, or the non-inverting input. This is the inverting input, and this is the output. And so you just attach all the things to where they need to go accordingly. So this would be attached to ground. This would be attached to your entire filter network, and this would be you would have your multiple feedbacks, which is the capacitor and the resistor, attaching to this part of the circuit, and so to this you attach your initial resistor, you attach your 500 ohm resistor with your 10K potentiometer, and then the rest of it goes to ground, and this part goes to ground, or goes to the audio signal in, and that part goes to ground, and this is your 80K resistor, and this is your 160K resistor, and this is your 10 nanofarad capacitor here, and then the other nanofarad, the other 10 nanofarad capacitor is actually in here as well. So that is the and these are all connected together. So if you work it out on the breadboard first, and then this LM324 actually has 4 op amps, so it has the same exact thing times 4, just mirror image of each other. So for anyone who's not familiar with it, check out the data sheet, but this is basically how it's configured. So as you can tell, I have it all memorized now because I've been doing enough work with them, doing the VU meter stuff. But anyway, if you guys have any questions or concerns, or if you want to see more stuff like this, comment, let me know. or if you want to see the circuitry on the audio amplifier I built with the VU meter and the spectrum analyzer, I would be glad to show you. But the video is long enough. Hopefully I explained things as well as I can. That's based on all the research I did to try to figure it out. It took me a week to try to engineer the wah pedal. But basically, the multiple feedback narrow band pass filter is the way to go for the wah pedal. Not for everything, but it's definitely worth it for building a wah pedal. And just remember that that there's three areas of voltage. This is ground, but this ground over here is really what's going on over here. You have your VCC here, and this is your negative VCC, or VEE, I guess they call it. And then this is your actual ground. And so this is, if you attach this all, I attached this all to a 9-volt battery. So I had, the way it works out when you make the circuit this way, this is positive 4.5 volts, this is negative 4.5 volts, and this is 0 volts. So this is your ground that you attach all the grounds to, but the actual op amp is connected to the negative side of the 9-volt battery. So hopefully that explains it. If you guys want to build it or want to show me put links to your own videos of how you made your own wah pedals, and if they sound better than mine, I'll be glad to use your circuits instead of mine for the next wah pedal that I make, in case I have to for my guitar playing children, and that's pretty much it. Thanks everyone, and have a nice Saturday.